everyone, and welcome to today's presentation on classifying SMS messages into spam or ham. In this presentation, we will be discussing a common problem in the field of natural language processing, which is how to differentiate between the messages that are unwanted and messages that are legitimate. In order to tackle this problem, we will be using a combination of four different techniques like term frequency, inverse document frequency, word to deck vectorization, and heuristic approach. Additionally, we will be fitting a variety of classification model to see which one works better. So in the data pre-processing, text data often contains a lot of noise and irrelevant information such as typos, punctuations, errors, stop words, HTML tags and special characters, which can negatively impact the quality of analysis. So in order to overcome these issues, we need to perform text cleaning. For classifying messages into ham or span, we need to perform the following cleaning steps. So removal of extra white spaces. These steps standardize the text to and remove any extra spaces that may have been introduced while the text was being collected or processed. So removal of stop words. Stop words are commonly used to words like the and of etc that do not add much meaning to the text, so they can be removed as they do not contribute much to the meaning of the text and can increase the computational time of the analysis. So we did the lemmatization also. In this step involves the reducing the words to their base form or lemma. For example, the words running, ran and run would be all be reduced to lemma run. This helps to standardize the text and make it easier to analyze. Now we now may be wondering why we haven't performed the removal of punctuation, stemming, and removal of numbers. These are the valid reasons for this removal of punctuation. In this case of studying messages into ham or span, punctuation can carry important information, and removing it may result in losing important information that can help in classifying the messages accurately. Stemming involves reducing words to their root forms, but it is not always accurate and can result in the words being reduced to a form that is not recognizable. So for example, the word running might be reduced to run, which may not carry the same meaning. So removal of numbers can carry important information, and removal them may result in losing important information that can help in classifying the messages accurately. So in the third, data exploration using the word cloud. Text analytics projects can involve a large amount of data, making it difficult to understand and draw insights from it. This is where word clouds come into the tool for data visualization that can help us to understand and classify messages into ham or span. A word cloud is a visual representation of most frequently used words in a text corpus. As we can see, most frequently repeated words in the spam are like free, call, txt, stop, reply, and in the ham are like call, grow, no, and more. The next slide will be explained by my friend Mahesh.
Vectorization is an important step in text analytics because it enables transformation of textual data into numerical data that can be analyzed and processed by machine learning models. By converting text into numeric vectors, machine learning models can make use of mathematical operations, perform tasks such as classification, clustering, or dimensionality reduction. This allows for effective analysis and understanding of text data. The extraction of insights and patterns that would otherwise be difficult and impossible to uncover. Term frequency is a simple but effective method of quantifying the importance of a word in a document. It is defined as the number of words appears in a document divided by total number of words. The idea behind term frequency is that more a word appears in a document, the more relevant and important it is to the topic of the document. So after performing count vectorization using TF, we found that there are 8014 unique words, which is going to be a feature in this data frame. Next, IDF, inverse document term frequency. On the other hand, it measures the importance of the word across collection of document, also known as corpus. It gives more weight to words that appear in fewer documents, as these words are considered to be more specific and relevant to a particular topic. So after using term inverse document term frequency, we found that here also 8014 unique words. Now, dog to vectorization technique. Word to vector is a method used in text analytics to convert words into numerical representation, also known as vectors. The goal of word to vector is to capture the semantic meaning of words so that they can be analyzed mathematically and processed by machine learning algorithm. Google's word embeddings make this possible by giving a word with a vector of 300 dimensions. So, after passing the data into doc2 vector, it gives 300 dimensions for all our messages. We created some heuristic features to approach this problem. Presence of phone number, presence of dollar sign, presence of capital letter. The more the phone number sign and capital letter present in a message is more likely to be a spam message. So we use the binary features to, to create these variables. Next, proportion of spelling mistake and proportion of punctuations. The more the proportion, the more likely to be it is spam message. Then using text bug library, we found the subjective score of each message. The more the message is subjective, the more likely to be a spam. Then using Badder library, we found sentiment score of each message. We created these 7 features and applied it in the model. Next, visualization and dimension reduction. Using PCA, we have reduced the dimension from 8000 to 1796. Since 1796 dimension plotted in a graph will be a descriptive, we plotted only the first two principal components for TF vectors, TF-ID vectors, for dog-to-vec model, and for heuristic models. The model fitting part will be explained by my friend Ashwin.
In this project, we have used 5 different machine learning models to classify SMS messages into ham and spam. We have used logistic regression, decision tree classifier, Adabos classifier, bagging classifier, and random forest. First, we have used a logistic regression model, which is used commonly for binary classification. Logistic regression models that establish the relationship between the dependent variable and one or more independent variables by fitting a logistic curve. Next, coming to decision tree classifier, which is a tree-based model that makes predictions by recursively dividing the feature space into regions based on the values of the input features. Then we used an Adabos classifier, which is an ensemble model that combines multiple weak learners to form a strong learner. In this project, decision tree were used as weak learners. After that, we used a bagging classifier, which is another ensemble model that combines multiple decision tree classifiers. However, unlike AdaBoost, bagging does not give more weight to the misclassified samples. Finally, we used a random forest classifier, which is an extension of bagging. Random forest adds the concept of random feature selection to bagging, which leads to further diversity in the trees and improved performance. After training and testing the models using a dataset of SMS messages, we found some of the insights from these models. Coming to logistic regression model on TF vector matrix. We have actually displayed the top 10 performing models, and the first model is logistic regression model on a TF vector matrix. Based on F1 score, this model has given an F1 score of 0.92. Coming to the second model, the logistic regression model on TF vector matrix with dimension reduction applied using PCA has given an F1 score of 0.91. The third model is a logistic regression model on TF vector matrix with dimension reduction using p percentage method. The F1 score corresponding to this model is 0.90. And coming to model 4, the F1 score is set to 0.90. On model 5, the ADA boost on TF-IDF vector matrix with dimensionality reduction using PCA had an F1 score of 0.89. The sixth model that we have used is a random forest model on TF-IDF vector matrix with dimensionality reduction using p percentage. The F1 score recorded was 0.72. Coming to the next model, we have a decision tree model, decision tree classifier model on a dog-to-vec method. The F1 score was relatively very poor. It resulted in a F1 score of 0.18. Coming to model 8, this is again a logistic regression model on dog-to-vec with dimensionality reduction using PCA with an F1 score of 0.97. And model 9, we have a random forest model with heuristic features that we have created on our own, which led us to a F1 score of 0.78. Coming to model 10, we have a bagged decision tree on heuristic features with an F1 score of 0.75. In conclusion, this project highlights the importance of text analytics in classifying SMS messages as either spam or ham. The use of multiple machine learning models allows us to compare and choose the best model for a particular problem. And coming to the observed performance, we found that the term frequency vectorization method performs well when compared to other three vectorization methods, followed by the heuristic approach. The heuristic approach performs better than Dr. Weck approach, and it performs well with only 7 features. That is a point to be noted. We observe that there is a great opportunity to develop more heuristic features which classifies the target accurately and are relatively easier to interpret other vectorization methods. We hope that our findings can contribute to the development of more effective methods for dealing the issue with spam messages.